Welcome back. Hey guys, it's Rishi once again, and we're back with part 2 of files and exceptions. I hope part 1 gave you a clear introduction as to how we can work with files, how you went and read an entire file at once, and then read through a file's contents one line at a time. Well, in this video, we'll be focusing more about exceptions and how to handle exceptions that you're likely to see in your programs, before finally learning how to store Python data structures so you can save information that your users provide, preventing them from having to start over each time that they run their program. So let's go ahead and dive straight into it. So let's start with exceptions. So now Python uses special objects called exceptions to manage errors that arise during a program's execution. So whenever an error occurs that makes Python unsure of what to do next, it creates an exception object. And if you write code that handles the exception, the program will continue running. And if you don't handle that exception, the program will halt and show a traceback error, which includes a report of the exception that was raised. And I know you guys are experts now at spotting what a traceback error is and how to resolve it. So exceptions are handled with try except blocks. Now, a try except block asks Python to do something, but it also tells Python what to do if an exception is raised. So when you use try except blocks, your programs will continue running even if things are starting to go wrong. And instead of tracebacks, which can be confusing for users to read, users will see friendly error messages that you write. So the first thing I'm going to do is look at a simple error that causes Python to raise an exception. I'm going to go ahead and create a new file called division.py. And you probably know that it's impossible to divide a number by 0. But let's ask Python to do it anyway. So let's go for print 5 divided by 0. Now, of course, Python can't do this, but let's print it out anyway. And we've got a traceback error. So, of course, Python can't do this, so we get a traceback error. And so the error reported here in the traceback is an exception object. And Python simply creates this kind of object in response to a situation where it can't do what we ask it to. So when this happened, Python stops the program and tells us the kind of exception that was raised. And we can use this information to modify our program. So we'll tell Python what to do when this kind of exception occurs. And that way, if it happens again, we're prepared. So let's now use try except blocks. So when you think an error may occur, you can write a try except block to handle the exception that might be raised. And you can tell Python to try running some code, and you can tell it what to do if the code results in a particular kind of exception. So let's take a look at what a try except block would look like. So let's go for try. And this is where we put our print 5 divided by 0. Okay, and then we'll put in an except. And this is simply zero division. And we're going to put this in our camel case, zero division error. And then we'll go ahead and print you can't divide by 0. And there we are. So we put print 5 divided by 0, the line that caused the error, inside our try block. And if the code in a try block works, Python skips over the except block here. And if the code in the try block causes an error, then Python looks for an except block whose error matches the one that was raised, and then runs that code in that block. So in this example, the code in the try block produces a zero division error. So Python looks for an except block telling it how to respond. And Python then runs the code in the block, and the user sees a friendly error message instead of a traceback. So let's now go ahead and run this, and we should see you can't divide by 0. And there we are. Our output is you can't divide by 0. Now, if more code followed the try except block, the program would continue running because we told Python how to handle the error. So let's look at an example where catching an error can allow a program to continue running. And that will be through using exceptions to prevent crashes. So handling errors correctly is especially important when the program has more work to do after the error occurs. And so this happens often in programs that prompt users for input. So if the program responds to valid input appropriately, it can prompt for more valid input instead of crashing. So let's create a simple calculator that does only division. So I'm going to go with print And let's go, give me 2 numbers, and I'll divide them. And then let's print, enter Q to quit. We'll start with while true, and we'll assign the first number to the input. Let's put a new line here, and then we'll go with if the first number is equal to Q, then break. And then we'll do the same, but this time we'll do it for the second number. So I'm going to copy and paste this just below here, but we'll change this to second underscore number, and we'll put that there with the end. Beautiful. So now we've got our if statements here. Let's go ahead and divide these so we can get our answer. So let's go for answer equals int, because we're working with integers. And let's go with our first number divided by our second number. And then we'll print our answer. Beautiful. So before we go ahead and run this, let me explain what's happening here. So this program prompts the user to input a first number and a second number. And if the user does not enter Q in the first point, then it will go to our second number. We then go ahead and divide these 2 numbers to get an answer. And this program does nothing to handle errors. So asking it to divide by 0 will simply cause this to crash. So let's now go ahead and run this. And let's give our first number as 10 and our second number as 0. And this will give us our error, which is the division by 0. So it's bad that the program crashed, but it's also not a good idea to let users see tracebacks. Non-technical users will be so confused by them, and in a malicious setting, attackers will learn more than you want them to from a traceback. For example, they'll know the name of your program file, and they'll also see the part of a code that isn't working properly. So a skilled attacker can sometimes use this information to determine which kind of attacks to use against your code. So this is where it brings me to my next point, which is the else block. So we can make this program more error resistant by wrapping the line that might produce errors in a try except block. And the error occurs on the line that performs the division. So that's where we'll put the try except block. And that will be around this part here. And this example also includes an else block. So any code that depends on the try block executing successfully will go directly in that else block. So let's now go ahead and write out our try. We'll keep our answer as it is. And just above, we'll put in our else block here. And just above, let's go for except ZeroDivisionError. And then let's go ahead and print out that you can't divide by 0. And then we'll finish off again with our else. So we asked Python to try to complete the division operation in a try block, which includes only the code that might cause an error. And any code that depends on this try block succeeding is added to that else block. And in this case, if the division operation here is successful, then we use the else block to print our result. And the except block tells Python how to respond when a zero division error arises. So if the try statement doesn't succeed because of a division error, then we print a friendly message telling the user how to avoid this kind of error. So the program continues to run and the user never sees a traceback. So let's go ahead and test this out. So remember again, we do not want to see a traceback error. So let's go for 6 and let's have our second number as 0. And this time you can see it states you can't divide by 0. So the try except else block works like this. Python attempts to run the code in this try statement. The only code that should go in the try statement is code that might cause an exception to be raised. So sometimes you'll have additional code that should run only if the try block was successful. And this code goes in the else block. The except block simply tells Python what to do in case a certain exception arises when it tries to run the code in the try statement. So by anticipating likely sources of errors, you can write robust programs that continue to run even when they encounter invalid data and missing resources. And so your code will be resistant to innocent users' mistakes and malicious attacks. So I hope that was a clear introduction. Let's now move over to handling the FileNotFoundError exception. So one common issue now when working with files is handling missing files. Now the file you're looking for might be in a different location, the file name may be misspelled, or the file may not exist at all. So you can handle all of these situations in a straightforward way with a try except block. So let's try to read a file that doesn't exist. And the following program that I'll be going through will now try to read the contents of a random file name, but I haven't saved that file in the directory as my py file. For those who watched our previous video, on one side we had a text file where we would have our text being presented, and then a py file, which is our Python file. So let's go ahead and write out our file name, and I'm going to equal this to rishi.txt. So this is where my output should be. I'll then open up with my with method, and I'll take my file name as f_object, which again is my file underscore object. And then I'll go for contents equals f_obj dot read, because I want to read that object. So now what you'll notice is that Python cannot read from a missing file. So it's going to raise an exception because currently we don't have rishi.txt anywhere here. So let me clear the terminal and we'll run this. Oh, beautiful. And there we are. We've got a FileNotFoundError. No such file or directory. So this last line here is the exception that Python creates when it can't find the file it's trying to open. So in this example, we've now got our open function, which produces the error. So to handle it, the try block will begin just before the line that contains open. So let's go for try. Let's then go ahead and tab these. And now let's put in our except, and that's the file not found. And you can see as I'm doing this, we've got file exists error and file not found. We're then going to assign a variable and say, sorry, the file, using our concatenation method, using our file name, does not exist. And then we'll print our message. Perfect. So in this example, the code in the try block produces a file not found error. So now Python is looking for an except block that matches that error and then runs the code in the block, and the result will be a friendly error message instead of a traceback. So let's go ahead and print this out. And there we are. Sorry, the file rishi.txt does not exist. So the program has nothing more to do if the file doesn't exist. So the error handling code doesn't add much to this program. So let's build on this example and see how exception handling can help when you're working with more than one file. So now you can analyze text files containing entire books. And many classic works of literature are available as simple text files because they are in the public domain. So the text that I'll be using in this section will come from Project Gutenberg. And I've put the link below for your information. So Project Gutenberg simply maintains a collection of literary works that are available in the public domain. And it's a great resource if you're interested in working with literary texts in your programming projects. So let's go ahead and pull in the text of Alice in the Wonderland and try to count the number of words in the text. And we'll use the string method split, which can build a list of words from a string. So let's take a look at what split does with a string containing just the title Alice in the Wonderland. So let's go for title equals. We'll also print this out using our split method, and let's see what's happening here. And what you'll note here now is that it's splitting each word. And so the split method is separating a string into parts wherever it finds a space and stores all the parts of the string in a list. So the result is a list of words from the string, although some punctuation may also appear with some of the words. So to count the number of words in Alice in the Wonderland, we'll use split on the entire text. And then we'll count the items in the list to get a rough idea of the number of words in the text. So I'm going to go ahead and change rishi.txt to alice.txt. And so let's go ahead and add an else block just beneath this here. So let's go for else. And now what we're going to do is count the approximate numbers of words in the file. So words equals contents dot split. And then let's assign a new variable, which is num words, and find out the length of these words. So now before I go ahead and print this out, I'm going to go ahead and create my alice.txt file. And I'm going to go ahead and paste out chapter 1 of Alice in Wonderland. So let's now go ahead and print this out And because I've created the file alice.txt and I've assigned it to the correct directory, the try block will work this time. So let's go ahead and print it out. And there we are. It states the file alex.txt has about 2,166 words. So what have we done here? Well, at line 43, we take the string contents, which now contains the entire text or the entire chapter 1 of Alice in Wonderland as a simple long string. And we use the split method to produce a list of all the words in the book. And when we use len on this list to examine its length, we get a good approximation of the number of words in the original string. And then the final line here, we print a statement that reports how many words were found in the file. And this code is placed in the else block because it will work only if the code in the try block was executed successfully. And so the output tells us how many words there are in the text. So let's now add more to this and let's work with multiple files. So now let's go ahead and add more books to analyze. But before we do, let's move the bulk of this program to a function called count_words. And by doing this, it will just make it easier to run the analysis for multiple books. So now what I'm going to do is create a function, and that's simply going to be count_words, and we'll put file name as our parameter. We'll then assign our file name as alice.txt, and count words will have one parameter, which is file name. So most of the code is unchanged here. We simply just indented it and moved it into the body of count words. And it's a good habit to keep your comments up to date as well when you're modifying the program. So we changed the comment. So let's go ahead and add a docstring to this function. And now we can write a simple loop to count the words in any text we want to analyze. And we do this by simply storing the names of the files that we want to analyze in a list. And then we can call count_words, which is our function, for each file in the list. So we'll try to count the words for Alice in the Wonderland and other novels, which are all available in the public domain. And I'm also going to intentionally leave a text file out of the directory containing word_count so we can see how well our program handles a missing file. So let's go ahead and write out our file names. I'm going to put this in a list. I'm going to start off with alice.txt, followed by Jekyll and Hyde.txt. Let's go for Gatsby, and let's go for inspector calls. And what I'll also do is I'll add one more, which is not going to be part of our files. So we can see again, just to reiterate, just how well our programs handle a missing file. And so let's go for great expectations.txt. Wonderful. So now we've got our file names. Let's go ahead and write our for loop for file name in file names. And then let's call our function count_words, and we'll go for our file name because we want to print out the individual file. So now remember here that the missing Great Expectations text file has no effect on the rest of the program's execution. So using the try except block in this example here provides two significant advantages. The first is that we prevent our users from seeing a traceback, and we let the program continue analyzing the texts it's able to find. And so if we don't catch the FileNotFoundError that Great Expectations will raise, then the user would see a full traceback, and the program would stop running after trying to analyze Great Expectations. And so it would never analyze your Great Gatsby or any of the other novels. So let's go ahead and print this out and see what we get. And there we are. We can now see that, the file Great Expectations does not exist. But the others, alice.txt, Jekyll and Hyde, Gatsby, and inspector calls, are all being shown. And the reason why these are being shown with these particular words is because I've created them. I've gone for my Jekyll and Hyde here, my inspector calls, and I've got my Gatsby written out. So I hope that was now clear. Let's move on into something deeper. So now in this current example, we informed our users that one of the files was unavailable, which was our Great Expectations file. but you don't need to report every exception that you catch. Sometimes you'll want the program to fail silently when an exception occurs and continue on as if nothing happened. So to make a program fail silently, you write a try block as usual, but you explicitly tell Python to do nothing in the except block. So Python has a pass statement that tells it to do nothing in that block. So now what we're going to do is after our print message and our except, we're simply going to write pass. So what we're going to do is after our except method, we're going to write pass. So let me comment this out and let's write pass. And so the only difference between this listing and the previous one is just the pass statement. So now when a FileNotFoundError is raised, the code in the except block runs, but nothing happens. No traceback is produced, and there's no output in response to the error that was raised. So users see the word counts for each file that exists, but not any indication of the file that was not found. So now what should we see? We should see all of these files below except for the Great Expectations output. So let's go ahead and print this out. And there we are. You can now see we've got Alice, Jekyll and Hyde, Gatsby, and Inspector Calls. We no longer have the Great Expectations file here. So the pass statement has now worked, and it also acts as a placeholder. It's a reminder that you're choosing to do nothing at a specific point in your program's execution, and that you want to do something there later. For example, in this program, we might decide to write any missing file names to a file called missingfiles.txt. And our users wouldn't see this file, but we'd be able to read that file and deal with any missing texts. So I hope that was a clear insight into how we can work with files and fail silently. But let's now move over to deciding which errors that we want to report. So how do you know when to report an error to your users and when to fail silently? Now, if users know which texts are supposed to be analyzed, then they might appreciate a message informing them why some texts are not analyzed. So if users expect to see some results but don't know which books are supposed to be analyzed, they might not need to know that some of the texts were unavailable. So giving users information that they aren't looking for can decrease the usability of your programs. So well-written, properly tested code is what you need to go for. But remember, it's not very prone to internal errors such as syntax or logical errors. A little experience will help you know where to include exception handling blocks in your program and how much to report to users about errors that arise. So don't worry right away. Anyhow, this brings us to the end of this section here. I've now got 5 programs I would like you to attempt. So pause the video here, attempt those 5 programs, and then press play when you're ready to go through them. Amazing. Welcome back. I hope those 5 programs have given you a better insight into files and exceptions. Let's now jump into our 6th program, which is addition. So one common problem when prompting for numerical input occurs when people provide text instead of numbers. So when you try to convert the input to an int, you'll get a value error. So we want to write a program that prompts for 2 numbers, add them together, and print the result. We also want to catch that type error if either input value is not a number, and then print a friendly error message before testing it out. So let's go ahead. Let's go for our try, and let's give 2 values here. Let's go x equals input, and we'll say give me a number. We'll then go ahead and assign this to int as an integer. So now we've gone ahead and we've done that. Let's go ahead and do the same, but for our second number, and let's assign this to our int y. So now we've gone ahead and done that, we need to accept a value error. And let's also print out a message saying, sorry, I really needed a number. Else, we want to go ahead and add both values. So we'll get a variable sum and equal that to x plus y before printing out this using the f method. We'll get our placeholders in place. So now we've gone ahead and done that. Let's go ahead and print this out. So what should our output be? Well, if we give a number, let's say 23, and another number 47, we should get our output. But if we give an integer as 23, but write 47 in words, we should get an error. So let's go ahead and print this and test it out. So give me a number, let's go for 23, and another number, let's go for 47, and we get our output. But this time I'm going to run it one more time, and one number is going to be an integer, and another is going to be a string. Okay, let's go for 23, and let's go for 10. And there we are. Sorry, I really needed a number. Amazing. So I hope you can see how we're working with our try and except value error to ensure we're getting the right data type every time. Okay, let's move on to the next one, addition calculator. So wrap your code from our previous exercise in a while loop so the user can continue entering numbers if they make a mistake and enter text instead of a number. So the first thing I'm going to do is go ahead and write out a print statement and say enter Q at any time to quit. And we'll also put this on a new line before going ahead and starting off with while true. And then I'll write out x equals input, and let's say give me a number. I'll then go ahead and put an if statement and say if x equals to q, then break. So what break is doing is simply ending our program if they enter quit. We'll then go for x equals int, and we'll assign it to x, and we'll do the same thing with our y. So let me go ahead and copy and paste this below, but I'm going to change my x to y, and let's go for another number. So now we've gone ahead and we've done that. Let's go for our except value error, and let's print this out, which is sorry, I really needed a number. And again, you can just copy out the previous program that we've been working with. Let's go with else, and let's put our sum, which is equal to x plus y, and then let's write out our print statement, which is what I'm just going to simply go ahead and copy from here, and let's paste it below. Marvelous. So let's go ahead and run this. Okay, so give me a number. Let's go for 23. Let's go for 47 as another number, and we've got 70. This time we're going to go for 3, and again it says sorry, I really needed a number, so let's go for the number 3. And this time let's go for the number 5, but we'll write it out as a string. Again, it's told me sorry, I need a number, so again this possibility is working out. And finally let's go for -10 and -2. Again, the sum, very good. And then let's go to Q for quit. And there we are. So we've tried out all the different possibilities, both with 2 numbers. They worked very well. Then we went for a string, and it gave me a value error. We went for a integer followed by a string. It still gave me a value error. And then we tried our negative numbers, and that worked out perfectly well. Amazing. So you've done really well. Let's now move over and comment out this code before moving to our next program, and that is cats and dogs. Alrighty. So this is now asking us to make 2 files, cats.txt and dogs.txt. And we need to store at least 3 names of cats in the first file and 3 names of dogs in the second file. So let's go ahead and do that here. Cats, plural.txt. And let's write out Leo, Nami, and Junior. We're then going to go ahead and do the same, but for this time it's going to be dogs.txt. And let's go for Millie, Cooper, and Julie. Okay, we've done that now. It then states that we need to write a program that tries to read these files and print the contents of the file to the screen before wrapping your code in a try except block to catch the file not found error and print a message to that. Okay, wonderful. I am going to create another one and call this cats and dogs.py. So let's go ahead and do that here. Wonderful. And let's write out our code in here. So I'm going to take my file names, put this in a list, and go for cats.txt as well as dogs.txt. I'm then going to put in a for loop, so for file name in file names, and go ahead and print this out here. So we'll go for our new line, we'll go for reading file, and then in our placeholder, we'll go for file name. Now we've gone ahead and done that, let's put in our try an accept method here. We'll go for with open, and let's go for file name as f. We'll then go ahead and write contents equals f.read because we want to read that file, and then print the contents. Now we've gone ahead and done that. Let's go ahead and write out our accept file not found, and then print out a message saying, sorry, I can't find that file. Marvelous. Okay, now we've gone ahead and done that. Okay, let's go ahead and clear our terminal before running this. And what do we see? There we go. Reading file cats.txt and reading file dogs.txt with our names in there. Amazing. So now the next thing we need to go through is simply moving one of the files to a different location on your system and making sure that the code in the accept block executes properly. So what I'm going to do is simply rename cats.txt and to keep it as dolphin.txt. I've now gone ahead and done that. Let's go back to our cats and dogs py and run this file. And there we are. It states, sorry, I can't find that file. Amazing. And that's both exceptions being made. Okay, let's go ahead and close this off. And let's jump back into 9.9. All right. Silent cats and dogs. So modify your accept block in our previous exercise to fail silently if either file is missing. So what I'm going to do is go back into my cats and dogs py. I've got my file names here with my for loop, my try and open, and the file not found. But this time I'm going to go with pass. So instead of the print statement here, I'm going to simply write pass. And then I'm going to put in my else and then print out the files. Let's also go ahead and comment the print contents out because we are bringing it down here, as well as our print statement here. Beautiful. Okay, let's go ahead and run this, and we should now see this output here. Okay, and before I run this, I'm going to go back to dolphin.txt and I'm going to rename this to cats.txt. And now we can go ahead and clear our terminal and run this. Okay, so we can now see reading files, cats and dogs. Wonderful. So this is now our output when both files exist. Let's now see the output when cats.txt has been removed. So go back into our cats.txt and rename this dolphins.txt. And let's go ahead and run this once more. And so what do we see? We've only got reading file dogs.txt. So this time we don't get an exception saying, sorry, I can't find that file. So this is an example of failing silently. Beautiful. All right, amazing. We've come so far, so keep up the great work. We're on to our final program now, and that's going to be 9.10. Beautiful. So in this program, I've asked you to visit the Project Gutenberg site and find a few texts that you'd like to analyze. Download those texts for these works or copy a raw text from a browser. And you can use our count method as we've done previously. One thing that I wanted you to notice was that converting the string to a lowercase using lower would catch all of the appearances of that word that you're looking for. So I want you to write a program that reads the file that you found and then determine how many times that word appears in each text. And this will be an approximation because it will also count words such as then and. So what I'm going to do is focus on one of the files I've already used, which is going to be inspector calls. And so I'm going to go with the word the. So I want to see how many times the is being called in inspector_calls. So what I'm going to do is go ahead and call a function and see this as count common words. Let's take file name and word as our parameter here. We're then going to put in our doc string. We'll then go with our try method here. So I've got my try, except, and else in place. And then that's going to follow through with my file name, which is going to be inspector_calls.txt, followed by my function, which is count common words, and my file name, followed by the word I'm looking for, which is going to be the. So now that is all said and done, let's go ahead and see. So now that is all said and done, let's go ahead and see how many times the appears in our inspector calls text file. So I'm going to clear my terminal and print this out. Okay, so what does it state? there appears in inspector calls text about 36 times. So again, this solution only examines one text, but the function can be applied to any number of texts. Amazing. So let's move back into our class file where we are moving over to the final part of this video. I hope you can see the value here, and I hope you're as excited as I am. So let's now move into our files and exceptions file where we will continue our program. Okay, so in this section, we're going to be focusing on storing data. So now many of your programs will ask users to input certain kinds of information, and you might allow users to store preferences in a game or provide data for a visualization. So whatever the focus of your program, you'll store the information that users provide in data structures, such as lists and dictionaries. So when users close a program, you'll almost always want to save the information that they entered. So a simple way to do this involves storing your data using the JSON module. So what is the JSON module? Well, the JSON module allows you to dump simple Python data structures into a file and load the data from that file the next time the program runs. And you can use JSON to share data between different Python programs. Even better, the JSON data format is not specific to Python. So you can share data that you store in the JSON format with people who work in many other programming languages. And it's a useful and portable format and very easy to learn. So what is JSON? Well, JSON stands for JavaScript Object Notation. And this was originally developed for JavaScript. However, it has since become a common format which is used by many languages, including Python. So within storing data, let's touch on using the dump and load method here. So let's write a short program that stores a set of numbers and another program that reads these numbers back into memory. And the first program will use the JSON.dump to store them, and the second will use JSON.load. And so what we're going to do is simply go ahead and import our JSON. And we'll take numbers in a list, and let's go for 2, 3, 5, 7, 11, and 13. So these are random numbers that I've got here. And so please remember that the JSON.dump function takes two arguments. It's a piece of data you want to store and a file object that it can use to store the data. So let's go for our file name and let's label this as numbers.json. We'll then use our open method and we'll take our file name and we want to focus on the write method. And we'll take this as f_object and then we'll use our JSON.dump, as you can see here, which will take the numbers, which is our first argument, and the second, which is the f_object. So now let's go ahead. What's happened here now is that we first imported the JSON module and then created a list of numbers to work with. We then went ahead and chose a file name in which to store the list of numbers. And it's customary to use the file extension .json, as you can see here. Then we opened the file in write mode, which is our W, which allows JSON to write the data to the file. And then we've used the JSON.dump function to store the list numbers in the file numbers.json. And so remember, this program has no output, but let's go ahead and open a file called numbers.json. And you can also see that the emblem has also changed. And so now it's an empty file here, but when we go back into our files and exceptions and run this, once again, you will see no output. But if we go into our JSON file, you will see our numbers being presented there. So now we're going to write a program that uses JSON.load to read the list back into memory. And this time let's go for file name equals numbers.json and take our open method here with file name as f_object and then keep everything else very much the same. But this time it's going to be a load function and we'll put our object in there. Marvelous. We'll then print our numbers. Beautiful. Okay. So now again, I've made sure that we're reading from the same file that we wrote to, and this time we open the file in read mode because Python only needs to read from the file, before finally calling our json.load function to load the information stored in numbers.json and store it in our variable numbers. So let's now go ahead and print this out. And there we are. We can now see that we've got our numbers in our terminal. So I hope you can see how this is a simple way to share data between two programs. So we finally loaded the numbers from our numbers.json file. But let's now take this one step further. Let's think about how we can save and read user-generated data. So saving data within JSON is useful when you're working with user-generated data, because if you don't store your user's information somehow, you'll lose it when the program stops running. So I'm going to take a look at an example where we prompt the user for their name the first time they run the program, and then remember their name when they run the program again. So let me go ahead and copy this out and paste it below here. So we've got our import JSON, which we're not going to change, but this time I'm going to declare a new variable and call this username and have our input to this and ask the user what their name is. Okay, we've now gone ahead and we've done that. We've got our file name, which is still within username.json. We are going to put this as our write method because we want to write to that file. And instead of our load, we're going to go with json.dump. And then this is where we will take our username and our f_object. And this time let's go for we'll remember you when you come back, followed by our username. So let's go ahead and print this out. Okay, what's your name? Let's go for Rishi. And we'll remember you when you come back, Rishi. Okay. So now let's go ahead and write a new program that greets the user whose name has already been stored. So now let's go for file name equals username.json. And this time I'm going to copy out these 3 lines here, but change it again from json.dump to json.load. So again, we don't need to write to this. So we're just going to have our file name as f_object, but then we'll take our username and equal this to json.load and f_object before printing out welcome back plus our username. So let's go ahead and comment out our code and print this out. And there we are, welcome back Rishi. So now we need to combine these two programs into one file. So when someone runs, let's say rememberme.py, we want to retrieve their username from memory if possible. Therefore, we'll start with a try block that attempts to recover the username. And if the file username.json doesn't exist, we'll have the except block, prompt for a username and store it in the username.json for next time. So let's go ahead and create a new file called rememberme. And within this, I'm going to import my JSON and let's print out the code that we have just written out. Amazing. So there's no new code here. Blocks of code from the last 2 examples are just combined into one file. So again, we've tried to open our file using our username.json. And if the file exists, we read the username back into memory and print that message welcoming back the user in the else block. And if this is the first time the user runs the program, then username.json won't exist and a FileNotFoundError will occur. And so Python will move on to the except block where we prompt the user to enter their username. We then use json.dump to store the username and print a greeting. So whichever block executes, the result is a username and an appropriate greeting. So let's take a look at the output if this is the first time a program runs. So let's go ahead and clear my terminal and let's print this out. Okay, let's go for Rishi Bagga. And we'll remember you when you come back, Rishi Bagga. Otherwise, if we run this once more and imagine this is the second time we're running our program, you can see it states welcome back, Rishi Bagga. So I hope that section was clear. So this now brings us to the end of our second section, where I've given you 3 programs to complete. So feel free to pause the video, attempt those 3 programs, and then press play when you're ready to go through it. Welcome back. Hey guys, I hope you found those programs useful. Let's now go through the solutions. So within our chapter 9 solution file, let's start with 9.11. So in this program, we need to write a program that prompts for the user's favorite number, and then use the json.dump to store this number in a file, and then write a separate program that reads this value and prints out a message. So let's go ahead and create a new file, and we're going to call this favorite number. And within this, we're going to import our JSON. We're then going to declare a variable called number and put in an input and say, what's your favorite number? We're then going to go ahead and write out our open method and say favorite number.json. We're using our write method here as f, before writing out our json.dump function. And within this, we'll take 2 parameters, number and our file. And then we shall print out a message saying, thanks, I'll remember that. Amazing. So let's go ahead and print this out. And there we are. Let's go for what's your favorite number? And let's go for 23. And there we go. Thanks, I'll remember that. And now we're going to go ahead and create one more file, but this time it's going to be a read only. So favorite number and read.py. And so again, we'll import our JSON. We'll go with open and favorite underscore number.json as f, and then we'll assign number to json.load. And we're only loading our file here before simply printing out, I know your favorite number. Perfect. And let's go ahead and print this out. Again, I've made a little error here, so let's add the B to number. Print this out once more, and there we go. I know your favorite number, it's 23. So as you can see, it's remembered the number that I had given previously when I was writing to this, and now when I'm reading it, it's simply giving me the number. Perfect. Let's go ahead and clear my terminal and move over to the next program and dive into 9.12. So this is where we need to now combine the 2 programs that we had previously written into one file. And if the number is already stored, then report the favorite number. If not, then prompt the user's favorite number and store it in the file. So let's go ahead and paste it out. And again, this is both of the files combined into one. And so as you can see, we've got our json.load and json.dump, followed with our accept method, which is FileNotFoundError. So let's now go ahead and print this out. And remember now, on our first run, we will tell the number, but on our second run, we'll come up with, I know your favorite number. So let's go with number 7. And then I'll run it again. And this time, I no longer need to say anything because it remembers what my favorite number was, and that is number 7. That's your Python magic. Okay, let's move over to 9.13. So this is our final program. And within this, the final listing for rememberme.py assumes either that the user has already entered their username or that the program is running for the first time. So we should now modify it in case the current user is not the person who last used the program. So before printing the welcome back message in greet user, ask the user if this is the correct username. So what I'm going to do is go ahead and walk through this with you. So I've got my import JSON and I've got my get stored username here. I'm then going to get another function, which is going to be to get my username, followed with the greet user function. So we've got our get new username, we've got our username, our file name, and our dump function with 2 of our parameters. So let's go ahead and see what happens here. Well, I know your favorite number, it's 7. Are you Rishi Bagger? Well, let's say yes. Well, welcome back, Rishi Bagger. Let's run it once more. Again, are you Rishi Bagger? Let's go for no. So now it's asking me my name, and let's go for Brad. And we'll remember you when you come back. So you might notice the identical else blocks that we have here. And one way to clean this function up is to simply use an empty return statement. And an empty return statement tells Python to leave the function without running any more code in the function. So let me now paste out a cleaner version of greet user. And so I will comment this out and paste this here. So we've got the same function, but this time we've shortened it by simply putting our return statement in, which eradicates the need for our else statement. So if we go ahead and print this, we can now see, are you Brad? And if we say yes, welcome back, Brad. And this is what we remembered last time. Amazing. So this now brings us back to the end of our chapter. So you read about exceptions and how to handle the exceptions that you're likely to see in your programs, before finally learning how to store Python data structures so you can save information that your users provide, preventing them from having to start over each time that they run the program. I hope you can see the power of Python and the endless opportunities that you have. So keep up the great work and continue programming. This is the only way that you can improve. And so now in our next video, we'll be learning efficient ways to test your code. And this will help you trust that the code you develop is correct. And it will help you identify bugs that are introduced as you continue to build upon the programs that you've written. For those who have come this far, I salute you. You've done really, really well. I can't wait to see you in the next video. Have a great day, and I'll see you then.